Alright, silly people, here's the situation. We have this Hamiltonian, which is defined by minus 2 mu over h bar times the dot product of s with b, where b, the vector, is just bx, by, bz, right? And s is the vector which includes um, all of the spin operators. Um, so just hopping right into it, the Hamiltonian, I'll write it out like this: Sx, Sy, Sz dot Bx, By, Bz. Now, I don't think the magnetic field components are actually operators. I'm pretty sure they're just physical quantities. So it's going to be 2 mu over h bar. It's going to be bx sx plus by sy plus bz sz. Um, and we happen to know that sx, sy, and sz are all just h bar over 2 times their respective Pauli matrix. So 2 mu over h bar over 2 bx sigma x plus h bar over 2 by sigma y plus h bar over 2 bz sigma z. Um, the h bars on the inside will cancel the h bar on the outside, and the 2's on the inside will cancel out the 2 on the outside. And you'll just have minus mu bx sigma x plus by sigma y plus bz sigma z. And we're meant to find the eigenvalues for that Hamiltonian. That's gonna be cool. Running this in matrix notation, you're gonna have, I'm gonna put this in brackets, 0 bx 0 is poly x, and poly y is 0 minus by I by 0, and then poly z is minus bz there. Just gonna make sure, yeah, I got the sign right on poly y. Okay. Adding these matrices together, the final matrix will be 0. Nope. It'll be bz bx plus by bx minus by bz minus bz actually. So finding the eigenvalues of that is just going to be solving this determinant, right? Gonna go ahead and cancel out the minus sign and the mu. That's gonna be minus bz squared minus b. Oh, you know what? I didn't even write the eigenvalues into this equation, which you definitely need. It's minus lambda and then minus bz minus lambda. Okay. Right, bz minus lambda, God, bz minus lambda times minus bz minus lambda um, minus bx plus iby, bx minus iby um, equals 0. Um, both of these have a similar form, so expanding them isn't too bad. You're just going to have bz squared or minus bz squared plus lambda squared minus bx squared plus I squared by squared is equal to 0, which will just convert that I squared into minus 1. Minus by squared equals 0. This can also be factored, as it turns out. Um, I'm just making sure I wrote my, yeah, I wrote my sigma 3 right. I got a different answer before, so now I'm in new territory. Uh, but still, this can be factored. It's just going to be lambda plus bz plus by plus bx times lambda minus bz minus by minus bx is equal to 0. Um, that makes sense to me. Yeah, yeah. So the cross terms are the things that cancel out in the end, and you'll just have all of the squared terms, big one minus little one, or lambda minus the other stuff. So setting one of these equal to 0, one of the other of these equal to 0, you can then just see that lambda 1 will be minus bx minus by minus bz, and lambda 2 is equal to bx plus by plus bz. Pretty cool.